Okay, so let's get started again with this idea. And the idea here I'm trying to offer is the fact that there's some really basic ideas that we can introduce, and in so doing, those ideas can be translated over to some of the online supplements and tools we have, but also in terms of some basic explicit instruction we can offer to the students. So for example, let's say that we're trying to take 1/2 and divide by a fourth, right? So we can represent that into how many 1/4 are in a half. We can represent that through ribbons, as we just had a moment ago, or through our ribbons here. We can also show it where we take, 1/2 of a ribbon, break it into fourths, put it within one hole to allow the individual to see those segments. And then we can also deepen that understanding within the division process, for example, by taking the divisor, the dividend, or both greater than 1, and then the problem in which the quotient or the integer, such as 13/4, divided by 1/2, can extend it from there. Now, another kind of simple aspect is estimation, right? But estimation allows for the individual to better appreciate the number, the value of the number, where it fits within that number line, where it fits within that visual. So for example here, starting off with just 2.5 times 1/4. Is it more or less than 1? Is it more or less than 2? And just starting up with providing those opportunities to kind of predict or judge, which then allows them to kind of begin to make computations with the fractions. Similarly, we have to address the misconceptions and the misconceptions regarding, procedural challenges with fractions. So for example, let's start off with the numerator and denominator. It's a common area, but here we know that students often misapply their knowledge of whole numbers into the application of the fraction. So where we need to break it down further is to, contextualize it, but be explicit. So for example, let's say if we have, 3/4 of an orange and we give 1/3 of it to a friend, what fraction of the original orange do you have left? Now, students that are doing the poor subtraction with the whole numbers may come up with an answer of, 2/1 or 2, and then they should immediately begin to recognize, wait a minute here, that's impossible because we started off with 3/4 of an orange and we made it even smaller. So it can't be 2. So these examples allow us to, the students to get motivated with, wait a minute, this is wrong, so what's right? Wait, I'm misapplying something I learned earlier, so what is the new element that I'm trying to learn? And this is where, oh good, opening for explicit instruction. And the student, the struggling student particularly, may be more receptive to that discussion and more receptive to, oh wait, I need to understand the appropriate procedures here. So with that thought, we have students that fail to convert the fractions, to equivalent forms with a common denominator before adding or subtracting them. So instead, they just insert the larger denominator, and they come up with the answer. And that's a problem. So with this underlying misconception, right, it can lead students to make the closely related error of changing the denominator of a fraction without making the corresponding change to the numerator, right? And then also, extending that into division, multiplication, etc. So visual representations that show the equivalent fractions, such as a number line or a fraction strip that we've already mentioned, can illustrate the need for the common denominator and the appropriate changes in the numerator. Simple stuff, but really important as we try to extend it. So here, for example, when adding or subtracting mixed numbers, students might ignore the fractional parts and work only with a whole number. Now this is extending the idea of, again, whole number, same concept we were just offering with the misconception with the denominator and the numerator. And it might allow students to translate problems like we have here into kind of incorrect assumptions. So what we need to do is we need to help students understand the relationship between the mixed number and the improper fraction and how to translate each into the other, basically to allow them to work with a fraction. So here, it might be through the number line, it may be through strips, it may be through other visuals, and that explicit instruction that they then can build upon. Finally, another element in terms of this might be the fact that, hey, take this half times a half, and it's half of a half. Oh, half of a half, so it's got to be smaller than a half. This conceptualization here allows them to kind of, again, understand how they're misapplying information, understand how it's relevant, and then from there, oh, the door's open for me to explain to you this new idea that you've been applying from whole numbers. Nope, we need to look at it upon differently, and here's how we need to look upon it differently. Now, we also find that individuals misapply the invert and multiply procedures for dividing by a fraction because they lack that conceptual understanding of the procedure. Back to the procedure. Again, now we're kind of ramping it up a bit from our basic procedure of denominator and numerator, and now we're bringing it into the inversion of fractions. So, for example, a student might solve a problem of 2/3 divided by 4/5 by multiplying the fractions without inverting. Okay, And and another common misapplication of the invert and multiply rules are inverting the wrong fraction, right? Or inverting both fractions. So basically, it's that lack of understanding, or this represents a lack of understanding of what they're supposed to do. So yes, explicit instruction, yes, direct instruction, yes, the visualization will allow the individuals to do it. And then in so doing, though, the teachers can begin by noting that, multiplying any number by its reciprocal product, for example, 1, and then dividing any number by 1 leaves a number unchanged. Oh, okay. And then teachers can show the students that multiplying both fractions by the reciprocal of the divisor is equivalent to using the invert and multiply procedure. For example, what? 2/3 divided by 4/5 is 2/3 as a dividend and 4/5 as a divisor, or we're multiplying both the dividend 2/3 and divisor 4/5 by the reciprocal of the divisor yields 2/3 times 5/4 divided by 4/5 times 5/4. So we can go on and on and on here, but the idea is that we're basically helping them with the inversion aspect for the multiplication procedure. All right. So next, we could present this kind of idea of real world contexts. And in real world here, yes, there's a box of chocolates, but the idea that the context should provide meaning to the fraction that quantifies the problem, right, for the individual. So for example, we could use, as we've already have, rulers and ribbons, but we can extend it to tape, or we can extend it to discrete items like a carton of eggs or a box of chocolates, or continuous ones like I mentioned earlier, pizzas, candy bars, etc. Students then can be helpful in terms of the sources of ideas for their context, and they allow the teacher to tailor problem to what they're familiar with and what's meaningful to the students, or at least a group of students, which could often be common for students. So, for example, it might be school events that everyone has in common, field trips or class parties or track and field days or ongoing activities that they're engaged in. They can all serve as that motivating context, allow for them to see the connection to the problem and then the instruction that follows afterwards. Okay, so we need to develop students' understanding, of the proportional relations as well before teaching the computational procedures. So we need to build on students, developing strategies for solving, for example, ratio, rate, proportion of problems. And there's ways of doing it. Now, one way here, and I know this is kind of small font, but basically it allows us to pose a story, right? Pose a problem that students use as a building strategy. So for example, here we're basically building up from, build up strategy here with that sample problem that goes into a unit ratio strategy, as you can see, that goes into a cross multiplication strategy or cross multiplication problem. Thus, the initial problem would involve ratios for which the students could easily apply a build-up strategy, such as what John is baking bread for some friends. He uses 2 cups of flour for every 3 friends. If he wants to make more bread for, let's say, 15 friends, how many cups of flour should he use, etc. So those types of elements allow for the individual to kind of take into consideration the ratio and the relationship there. Okay, now let's kind of extend that. So here's another problem. And so here, the element that we're trying to get into here, for example, is the students could be encouraged to solve the last problem with a cross multiplication strategy, writing the equation 2/8 equals cross multiplying to find the missing value, and then after students arrive at the same answer, all right, teachers can help lead the students into a discussion of why the unit ratio and the cross multiplication procedures yield the same answer. Students then could practice with both problems that are solved easily through the informal reasoning and their mental math, hopefully, and with the problems that are solved easily using cross multiplication, but not through the buildup of the unit ratio strategies. And here they can encourage students to discuss how to anticipate which approach would be easiest. So again, we're kind of introducing them to the different elements. We're having them conceptualize the different elements. We're being explicit about those. And then, of course, they can practice and apply what would be most appropriate for them. And so here's another example, encouraging students to use that visual representation. Here, basically select representations that are likely to elicit insight for the student for the ratio, rate, or proportion. And then identify the amount, for example, in this instance, the amount of flour needed for 32 people when a recipe calls for 1 cup of flour to serve 8. And they can use that ratio table to repeatedly add 1 cup of flour per 8 people to find the correct amount for 32 people. And again, alternatively, students can use the ratio table to see that multiplying the ratio by 4/4 or 4 times the recipe, provides the amount of flour needed for 32 people. So using this visual representation offers, a reference point for the individual and for the teachers that can point out as they discuss with students why multiplication leads to the same solution as a build-up strategy. So again, another way, but a way of connecting things. Here, visual representation, here's something they can connect to in terms of recipes. Maybe they even make some of those recipes to then make the connection to the fraction. So we also need to provide opportunities for students to use and discuss alternative strategies for solving ratio, rates, and proportion problems, right? We mentioned that earlier. So here's another way of considering it. So teachers can pose problems based on the unit price of an object, right? Such as comparing the value of 2 items. So a 16-ounce can of soda for 89 cents to a 12-ounce can of soda for 62 cents. We can bring them to the grocery store. We can bring some of those items in. We can bring items in that they're actually looking to purchase. And they then can determine how much a certain amount of an item costs given the cost per unit and the number of units purchased. And the context of unit pricing problems can be, buying or selling, something at the grocery store, or cans of paint, or any of the purchasing, CDs or iTunes, whatever it may be. But you're getting the point in terms of that unit aspect. They can also help students solve in terms of scaling. And here we can offer the students that enlargement or reduction. For example, it could be a photo or a drawing or some sort of geometric shape, or something that allows for doubling the width or doubling the length. To create something new. Like, let's say we want to increase the size of a photo so we can see what's in the photo and a little bit more, elements that are allow the photo to be blown up. Or we can scale in terms of like a map and a legend. And that may not be as relevant, but to understand the distances between, let's say, 2 cities, a rival city, or things like that. But that would be based on the distance of the map. All right, so scaling is another aspect. And by the way, Khan Academy does some really nice examples of scaling. And this is just a screen capture of them trying to work it out and break it out. Another element here in terms of recipes, and cooking, they provide useful settings for ratio and proportional problems, right? And here's a good example off of education.com, and I'll make sure I offer that link outside of this resource. But for example, if a recipe calls for 1 egg and 3 cups of milk, and then the cook wants to make as much as possible using 8 eggs, because that's what they have, how much milk is needed? Assuming that the ratio of the eggs, in terms of that connection to the milk, and the original recipe is maintained. So students then, revise the recipe, they make more or less of the final amount. And again, something real, something tangible, something that they can use in respect to that ratio and proportion of the problem that, again, allows them to apply the fraction. So all these are ideas to, 1, practical, 2, things to find within a blended learning opportunity that already exists, let's say in the Flora virtual curriculum or in the IXL or in Khan Academy. And then also things that we might want to take a step back and say, okay, we need to introduce this idea. We may need to bring out some strips. We need to bring out some ribbons. We need to bring out some number lines to be able to make sure that they conceptually have this down and balanced and founded, and then we can build upon from there. So there's just some ideas. Hopefully those ideas are applicable. Hopefully the resources I shared beyond this and some of the activities give you some examples of where to find some of these things to be able to apply. And again, hopefully this has connected a few ideas, some tips, some potential solutions for helping those struggling learners and those with disabilities when it comes to fractions.